Good afternoon, class. Here's the second part of section 4.2, how derivatives affect the shape of a graph. So let's look at this example. We want to sketch the graph of f of x equals 1/2 x to the power of 4 minus x squared. And here's the steps that have been explained. And I like to graph this without, again, paying any attention to calculus and use prior knowledge of mathematics, starting with intercepts. So we're going to set y or f of x equal to 0. To do so, we are going to do the factoring. We can take out either x squared or half of x squared. If I take half of x squared, it becomes x squared minus 2. And by setting it equal to 0, either x is 0 or x squared equals 2. That means x is plus minus square root of 2. It results in three intercepts: 0, 0, minus square root of 2, 0, square root of 2, 0, and 0, 0 is both x as well as y intercept. So if we were to graph this, so obviously this is 0, 0. Square root of 2, it's almost 1.41. It's here and here. Also, x squared, that means the multiplicity is 2, and that means 0, 0. The graph can't cross. Finally, if you look at the end behavior, if you look at the first term, the leading term, then that means the first and the second quadrant. That's where we find the end behavior, because the exponent is even and the leading coefficient is positive. Ultimately looks like y equals x squared. Therefore, if we were to graph it, it looks something like this. It will go down like that, and it has to come back up at some point. It hits the next point, x-intercept. It goes back down and then up. As you can see, it can cross minus square root of 2 comma 0 as well as square root of 2, 0. Furthermore, we can try the symmetry. I hope you see that f of minus x equals f of x. Convince yourself that's the case by just evaluating. That means the right half and the left half are identical. That also helps with graphing. This is what we did in algebra. So we have an idea. Now let's make it more detailed using calculus as well. So we are going to start with, besides the intercepts, start with f prime of x in order to do the first derivative test, which requires a sign graph. So what is f prime? Half times 4 is 2, 2x cubed minus 2x. You can factor the 2x out, you get x squared minus 1. And this is x plus 1x minus 1. So 2x times x plus 1 times x minus 1. When you set it equal to 0, either x is 0, negative 1, or positive 1. So there are three critical points. We go with a number line from negative to positive infinity. At the bottom here is x, and we put these three numbers in order from smallest to largest, minus 1, 0, 1. And at top here, we put the function that we want to do the sign graph on, which means f prime of x, and it happened to be 0 at each of those. Now we use TPs, test points. Over here is like -2, -0.5, +0.5, and 2. Before we move on, I want you to pay attention to the factored format of f prime. It has 3 answers, it has degree 3 and has 3 answers right away. That means they will alternate. Or if you look at the exponents here, no exponent, that means exponent is 1 here. Each one is odd, then they have to alternate. So, of course, pay attention to this number because it can make a difference. For example, if I use number 2, so 2 is positive, then you put 2 here is positive, 2 plus 1 is positive, 2 minus 1 is positive, all of them are positive, the product is positive. So if it's positive here and it will alternate, negative, positive, negative. If you have doubts, use the test points. I'm going to throw in the arrow, a negative arrow down, positive arrow up. That will help us see decreasing, increasing, decreasing, increasing. As it changes from decreasing to increasing, it gives us a local minimum. As it changes from increasing to decreasing, local maximum. Again, decreasing to increasing, local minimum. So the local minimum occurs at x equals -1, also x equals 1. We're going to put it in to find the y coordinates. It happened to be the same because whether I put -1 or +1 when I raise it to the power of 4, which is an even number, when I raise it to the power of 2, which is an even number, makes no difference. So either one of them becomes 1. In other words, this is 1, this is 1. So we are looking at 1/2 times 1 minus 1, which becomes -1/2. And we say local minimum is -1/2 at x equals +/-1. So we write the two pairs, -1, -1/2, +1, -1/2. Those are the local minimum. Local maximum happens at 0 because we already know 0, 0. You don't have to plug in. That means local max is 0 at x equals 0. So we have that. As mentioned, negative means decreasing. So it's decreasing from -infinity to -1. Union 0 to 1. It's increasing here from -1 to 0, union 1 to infinity. So as you can see, the first derivative test gives us a lot of information. So let's write everything here because we need to move on to the next page. Here's the function. Here's f prime. Here's the intercepts. Here's the minimum. Here's the maximum. Here's where the function increasing. Here's where the function is decreasing. So we are repeating that for the sake of graphing on this page. We are going to move on to the inflection point, which means now we need to find f double prime. So what is f double prime? 6x squared minus 2. Since we want to set this equal to 0, we're going to factor the 2 out. We get 3x squared minus 1. And if I set this one equal to 0, x squared is 1/3, and x is plus minus 1 over square root of 3. So we're going to go with the sign graph for finding possible inflection points. IPs at these two. We don't know until we do the sign graph. So we have a number line that goes from negative to positive infinity. And we have x here, we have f double prime. So x would be minus 1 over square root of 3 and positive 1 over square root of 3. F double prime would be 0. So over here goes the function of interest. In this case, f double prime. So what happens in between? Obviously, you don't even have to know the approximation here to recognize this is negative, this is positive. So for TPs, In between would be 0. 1 over square root of 3. Square root of 3 is larger than 1, so 1 over square root of 3 makes it smaller than 1. So those are easy points. However, if you go back to this one, f double prime is degree of degree 2 has two answers, or in other words, if you factor it, so they have to alternate. All you have to do, plug one of them. The easiest one would be 0, gives you -2. So if it's negative, they will alternate. And again, if you have doubts, just plug in the rest and check it out. For example, if I plug in -1 here, I get +1 times 6. 6 minus 2 is positive, just for the sake of argument. So positive means concave up, negative means concave down. So it's concave down between these two numbers from -1 over square root of 3 to 1 over square root of 3. Concave up from -infinity to -1 over square root of 3 union 1 over square root of 3 to infinity. And because of the change, as it changes from positive to negative and negative to positive, it creates an inflection point. So we do have two inflection points at this point as well as this point. What is the y coordinate? Plug in, and because again both of them have exponent, even doesn't matter, negative or positive result in the same thing. So let's plug. When we plug in, and I'm going to erase my work. First, I want you to notice this one is 1/3. So to the power of 4 makes it 1 over 9. And becomes 1/2, because 1/2 times 1 over 9 is 1 over 18. Minus 1/3 means -6 over 18, which is -5 over 18. And now we have everything we want, and we write the IPs, or inflection points, at x equals ±1 over square root of 3. And we have the pairs. Now, I go with an approximation because of the graph. Otherwise, this would be an exact answer. Perfect, you're done. But for the sake of graph, we want to go here. So let's write what we know. The x-intercepts at ± square root of 2, or roughly ±1.410. Also 0, 0, which is also a maximum, the inflection points, the minimum. And let's start graphing, starting with this one. Okay, remember this is 1, 2, this is -1, -2. So -1.41 is somewhere here. A +1.41 is somewhere here. Then we have 0, 0. And because it's a maximum, we put a double arrow. We move on to this one, -0.6, and this one is almost -0.3, so roughly -0.6, -0.3 puts us here, and +0.6, -0.3 puts us here. So those are the inflection points. Finally, the minimum, -1 is here, -1/2 puts us here, and because it's a minimum, we put a double arrow. On the right side, +1, and -1/2 is here, and again we put an arrow, and recall 1/2 x to the power of 4. That means this is the end behavior, and so you have the notice. Local max, local mean, local mean. Inflection point, inflection point. The function is concave up here, concave down here, concave up here. The graph indicates everything with details. Example 3, the number of bacteria in millions present in a culture at time t in hours is given by n of t equals 2t times 5 minus t quantity squared plus 14t plus 100. Find the initial population. What do we mean by initial population? at time t equals 0. So we want n of 0. And I hope you see if I plug in 0 here, because this is 2t, this goes to 0, this goes to 0, so we get 100 million bacteria. So that's elementary algebra. At what time before 10 hours will the population be maximized? Uh, in order to get there, first let me distribute and combine them. It makes it easier from there on, because we need to differentiate. So this one is 10t minus 2t cubed, 10t and 14t add up. So we want to put them in descending order from negative 2. So n of t is negative 2t cubed plus 24t plus 100. And it says before 10 hours, that means 0 to 10, why 0? Because we're talking about the time. So is 0 included? Yes. Is 10 included? No. So if you look at the extreme value theorem, it says if the function is continuous, this function is continuous because it's a Q function, the degree is 3, it's a polynomial of degree 3, and a closed interval. This is half closed, half open. That means this one can't be calculated. So you have to look at the endpoints, but only one of them. So f of A, but not f of B. Also critical points. We are going to differentiate. And because we're going to differentiate, I use this one. It's easier. So n prime is minus 60 squared plus 24. We are going to set it equal to 0, so I'm going to factor the negative 6 out. T squared minus 4, which is t plus 2t minus 2. And there are two answers when you set this equal to 0. Negative 2 and positive 2. And is positive 2 in between? Yes. Is negative 2 in between? No. And t is only 2. So we have one critical point, which makes it, when we plug in, if it's larger than that, makes it an absolute max. If it's smaller than that, absolute. So having said that, because this is half closed, half open, I want to go with the first as well as the second derivative test to further investigate that. So with a number line from negative to positive infinity, we're going to go from 0 to 10 and put the 2 in between. As you know, you need a test point. To the left of 2, you can even use 0. Everybody. Okay. If you put the 0 here, you get positive 24, and they will alternate because each one had degree 1, or you can even use 10 for that. So a positive means arrow up, arrow down, increasing, decreasing, increasing, decreasing. That means it's a maximum. Maximum occurs at t equals 2. It's a local max, but because we're dealing with the absolute value of closed interval theorem, it's an absolute max. The second derivative test, so first let's differentiate it again. We get negative 12t. The methodology is that you plug in and you see whether it's positive or negative. So if I plug in 2, I get negative. I don't care it's negative 24 or any other number. I'm just interested in the sign. Negative means what? Concave down. Concave down looks like that. So what is that? Maximum. So maximum occurs at t equals 2. So if you want to find the maximum, you plug in 2. Whether you use this one or this one makes no difference. It's easier to evaluate it with this because 2 squared is 4. 5 minus that is just 1. So 2 times 2 is 4, plus 14 times 2, 28, 32 and 100, 132 million bacteria. So it's pretty straightforward, everybody. All right, we want to sketch the graph of f of x equals x minus 2 to the power of 2/3 plus 1. I hope you remember we've looked at this as far as extreme value theorems concerned. So how do we graph it? First, I want to graph this using algebra, pre-calculus, reminding you of transformation, starting with the basic function. So we're going to rewrite this as a cube root of x minus 2 quantity squared plus 1. So we notice that the basic function needs to be used is the cube root of x. So we all should know how it looks like, cube root of x. And it has a domain and range all real numbers. The intercept is at 0, 0. The next step is cube root of x minus 2. And compared to this one, what happens if x is replaced by x minus 2, it shifts right by 2 units. So the same graph moves to the right by 2 units, and 0, 0 now has coordinates 2, 0. The next step is to look at the cube root of x minus 2 quantity squared. What is the effect of that? When you raise the function to a power, if the power is odd, the positive side gets just larger along the positive side, and the negative along the negative side, that means more negative. But when it's even, the positive side gets larger, the negative side flips over and gets larger, okay? Because this is an even exponent. So even the negative side becomes positive, and 0, 0 moves to 2, 0, and 2, 0 remains intact. The final step would be plus 1, which means now this graph, we are going to move it up, shift it up by 1 unit. So this goes up by 1 unit. Therefore, this 2, 0 has a new location 2, 1. That's the graph. You're done. Of course, you should always discuss the intercepts. X is 0, find y, y is 0, find x, and we will do that later on. But this is a transformation. You have the graph. So what we are going to do, we are going to use the first derivative test and find out where the function is increasing, decreasing. Do we have a local max, local mean, and so forth? And to do so, we are going to differentiate this. To differentiate, we are going to move on to this piece. We've already done that, so I'm going to remind you it's 2/3. X minus 2 to the power of 2/3 minus 1 makes a negative 1/3. The derivative of the inside is 1. And we're going to rewrite this by taking this down to the denominator, making this positive 1/3 or cube root. Now, f prime is 0. If the numerator is 0, numerator is a number, can never be 0, has no solution. F prime does not exist if the denominator is 0, and if you set the denominator is 0, x becomes 2. Therefore, as far as the sign graph from negative to positive infinity, we can put 2 here. At 2, f prime is undefined or does not exist. Now, use a test point to the left of 2 and to the right of 2. So TP's, obviously, easiest point on the left would be 0, on the right would be 3. If I put 0 into f prime, this one, 0 makes this negative, cube root is negative, everything else is positive, so the result is negative. If I put 3 here, everything is positive, so this is negative, this is positive, and I'm going to throw in the arrows, negative arrow down, positive arrow up. So the function is decreasing from negative to negative infinity to 2. The function is increasing from 2 to infinity because it's positive. And because of the change, then at x equals 2, we have a local minimum. So what is the y coordinate? You have to go back to the original function f of x. If I put 2 here, this goes to 0. The answer is 1. So local minimum is 1 at x equals 2, or simply the pair 2 comma 1. There is nothing else, so there is no local max, everybody. As mentioned, the function is decreasing here. This is negative from minus infinity to 2. Increasing here from 2 to infinity. So that's the first derivative test, giving us a local minimum, giving us intervals of increasing, decreasing. The next one is finding inflection point, if we have any, by finding f double prime. So what is f double prime? We're going to go to f prime, this format, and we're going to differentiate 2/3 times negative 1/3. The product of these two, everybody, is negative 2 over 9. X minus 2, subtract 1, you get minus 4/3. The derivative of the inside is 1. My assumption is we have no problem differentiating. So negative 2 over 9, x minus 2 to the power of negative 4/3. We're going to rewrite this by taking this down to the denominator and raising it to the power of positive 4/3, or f double prime is minus 2, 9 cube root of x minus 2 to the power of 4. Now notice, because this one, regardless of what it is, to the power of 4, is always positive, so is 9, this makes it negative. This expression is always negative, except when the denominator is 0 at x equals 2. So we're going to write it's less than 0 as long as x not equal to 2. Well, if this is always less than 0, it's always concave down, except at 2. So we write down it's CD, concave down from negative infinity to 2, union 2 to infinity. So you don't need to do a sign graph, but for some reason you don't recognize this. You may do a sign graph. If double prime is 0, there's no solution. If double prime doesn't exist, x is 2. You do the sign graph. From negative infinity to infinity, you put the 2, it doesn't exist. To the left of negative, to the left of 2, for example, you pick 0. If you plug in, becomes negative, this makes it positive, times 9 is positive, this makes it negative. To the right of 2, for example, 3, the same thing, this makes it negative. So you get to the same result. Again, if you don't recognize this, you may go with the sign graph. So now we want to graph this, and we haven't got the intercepts. We want to find the intercepts too. So number one, here's the function. Here's the function where it's increasing, decreasing, concave down, minimum. These are the information we just found. So let's find the intercept. To find the intercept, if you set x equal to 0, you find y. So if I set x equal to 0 here, again, minus 2, square root is 4, cube root of 4 plus 1, precisely. And I put about 2.587 for 2.6, let's say, because I want to locate on the graph. Okay, that's why I go with the decimal. Precisely plug in 0, minus 2, square root 4, cube root of 4 plus 1. So, what about x-intercept? We don't have any. Why not? Let's justify. X-intercept, you set this equal to 0. To set this equal to 0, we're going to move the plus 1. To the right becomes negative 1. Now we're going to raise both sides to the power of 3 to take this outside. If I raise the left side to the power of 3, it just comes out as x minus 2 squared. This one minus 1 cubed, which is negative 1. X minus 2 squared, can it be a negative value? Doesn't matter what number. No. Can it be 0? Yes, but can't be negative. Okay. Therefore, there is no solution. So how do we graph? Let's put everything we have. We have only 2 points. We have the y-intercept and the minimum at 2, 1. Let's pick a few easy points. So I'm going to start with 1. And if you put the 1 here, see how easy it goes? 1 minus 2 is what? Negative 1. Cube root, negative 1 squared, positive 1 and 1 is 2. Okay. Another easy point would be 3. If I put 3, I get the same thing. 1 cube root is 1 squared, 1 and 1 is 2. Now, a few more easy points. First, negative 1, on purpose, I picked something that I can't evaluate it or use a calculator, but negative 6. If I put negative 6 here, with minus 2 is minus 8. Cube root is minus 2. Squared, 4 and 1 is 5. If I put 10, 10 minus 2, 8. Cube root is 2 squared, 4 plus 1 is 5. So let's plug in. Starting with this, and I'm going to go with 2.6 roughly. So this is 0, 1, 2, 3, 4, 5, 6. So this is 2. 2.6 is roughly there. Then the next one is 1, 2. So 1 to the right, 2 up. The next one is 2 to the right, 1 up is here. And this is also a minimum. So we make a point of it. 3, 2, 1, 2, 3, 1, 2 is here. Negative 1, 3.08. So this is negative 1 and 3 is here. 3.08 is a little bit higher. Minus 6, 5. So this is minus 5, minus 6, and go up 5. 10, 5. So here's number 10. Go up by 5. It's here. And now if you graph it, you have a perfect graph. And every piece of information is there. Notice the function is decreasing here, increasing here. Decreasing means f prime is negative, and increasing means f prime is positive. Notice it's concave down here and here, and the minimum at 2, 1. Every piece of information can be found here.